Still on the topic of light and the path that light takes through the eye, and our third learning objective is to describe accommodation and the associated changes that occur in lens structure. So we've discussed that light passes through the cornea, the anterior cavity, the pupil, lens, and the posterior cavity, and is then projected onto the retina. But what happens as light passes through those substances of varying density is that the light bends or refracts. So to ensure that we get a clear image and focus correctly on an object or an image, the job of the lens is to accommodate. This means changing shape so that the light is projected onto or near the fovea centralis, which remember is the part of the retina with the highest amount of cones and therefore will provide the sharpest and the clearest image. So accommodation is the ability of the eye to change its focus from distant to near objects and vice versa. And it's achieved by the lens changing its shape. When the lens changes shape, the light bends either more or less sharply to focus on the fovea centralis and the macula lutea in the center of the retina. If we first take a look at this image on the left, and this is a lens that is set up to focus on an image which is up close. When the distance between an object and the eye is short, the lens is round or thicker, and this lessens the focal length. Focal length in relation to accommodation of the eye simply refers to the distance between the lens and the retina. When the eye accommodates to focus on objects closer to the eye, the lens becomes more rounded, which increases its refractive power, which is just how much the light bends or changes angle as it's decreasing its focal length. Looking at this image on the right, and when an object is further away from the eye, the light needs less refraction or less bending when it passes through the lens, and therefore the lens becomes flatter or thinner. This reduces its refractive power so that light bends less sharply and increases its focal length. Now, accommodation is controlled by our ciliary muscles, which adjust the shape of the lens to achieve proper focusing. When the lens is more round, to view images up close, the ciliary muscles contract, which actually loosens the ciliary processes and the lens becomes more rounded. When the lens is flatter, to view images further away, the ciliary muscle is relaxed, which pulls those processes tight, and the lens is stretched out. Now, this ability to accommodate decreases as we age due to a decrease in the flexibility of the lens as well as weakening of the ciliary muscle. And it's why we can find it harder to focus on things as we age. Now, a bit of a recap. Accommodation is the ability of the eye to change its focus from objects that are far away to objects that are up close and vice versa. To do this, the lens changes shape, which is assisted by the ciliary muscle and the ciliary processes. When an object is up close, which is the image we can see here, the lens is rounder and thicker. That increases refractive power, so it makes the light bend or refract more sharply. And when the lens is rounder, the focal length is reduced. So our focal length is the distance between the lens and the retina. Now, when an object is further away, the lens will become flatter and thinner. The light will refract less sharply or bend less sharply, and the focal length is increased.